Alright guys, today we are looking at multiplying and dividing rational expressions. So the big thing for you to know is that you cannot just cancel like this and say that x squared divided by x squared, that's good, we just have 2x. That's not possible. That x squared minus 2x, those are grouped together. So you can't just rip them apart and divide only x squared by x squared. You also have to divide the minus 2x by x squared. So when it is in simplified form, the numerator and the denominator have no common factors. So what you're going to want to do is to try to factor out everything you can, because you can cancel things out that are multiplied. So if I look, the numerator, x squared minus 2x, I can take out an x, and then I'm left with x minus 2. The denominator is just x squared, but as a reminder, that means x times x. So then that means that I can cancel out one of those x's, and I'm left with x minus 2 over x. Very tempting to go ahead and try to cancel out those x's, but we can't do that. This is the most simplified that it gets because that x minus 2 is grouped together. All right, let's take a look at this next one. So x squared minus 5x minus 6. So I need two numbers that multiply to negative 6 and add to negative 5. So I know that one has to be positive, one has to be negative, and I want the bigger one to be negative so that it adds to negative 5. So that should be negative 6, positive 1. And then x squared minus 1, that's one of our special patterns, difference of squares. So I get x plus 1, x minus 1 when I factor that out. So if you notice, we have x plus 1 and x plus 1. Yes, those do have addition, but they're both multiplying to something else. Both of those x plus 1s are identical. So then we're left with x minus 6 over x plus 1. And that's as simplified as we can get it. There's nothing else we can factor. There's nothing else we can cancel. All right, and then looking at this last one, x minus 2, really not much we can do. But x cubed minus 8, difference of cubes. We are thinking SOAP here. Remember that we take the cube roots. So I get x and 2. And then I square it. I multiply. And I square it. And then SOAP, same sign, opposite sign, always positive. And then you can see this x minus 2 and x minus 2 matches. So I'm left with nothing in the numerator, which means that it's just going to be a 1 in the numerator. And then I have x squared plus 2x plus 4 in the denominator. All right, let's look at some more. So multiplying is going to be very much the same. When we multiply, we are going to multiply across the top and multiply across the bottom, and then simplify what we can. Sometimes it'll make more sense to simplify before you try to combine everything, and sometimes it'll make more sense to multiply and then simplify. It just depends on the situation. In this first one, I'm going to go ahead and combine all of the pieces. So 6 times 10 is 60. I have x squared times x to the third. Remember, when you multiply, you add the exponents. So then I get y to the 7th. And then 18 times 2 is 36. I just have x squared, and I have y to the 4th. So when I simplify this, 60 over 36, both of those will divide by 12. So then I have 5, and I have 3. Then x to the 5th over x to the second, I divide, so I'm subtracting, that's x to the positive 3. Y to the 7th over y to the 4th, that's y to the positive 3. That's as simplified as it gets. Okay, but looking at this one, I think it's probably easiest to go ahead and split out anything I can before I try to simplify anything out. So let's see what things we can take out before we multiply it back together. So in the numerator of the first one, it looks like I can take out a 3x. When I take out a 3x, I have 1 minus 9x squared. In the denominator then, I want to see what I can factor 3x squared minus 2x minus 1. So I need to multiply to negative 3. So let's see, multiply to negative 3 and add to negative 2. So I need negative 3 and positive 1. So I'm going to break that apart. So 3x squared minus 3x plus x minus 1. So then I have 3x, x minus 1, plus 1, x minus 1. So this is going to look like 3x plus 1 and x minus 1. Okay. Over here, that denominator of 3x is just going to stay 3x. And then I have 3x squared minus 4x plus 1. So I needed to multiply to 3 and add a negative 4. So negative 3, negative 1. So I have 3x squared minus 3x minus 1x minus 4. So I have 3x taken out. So I'm left with x minus 1. And then I have a minus 1 that I take out. Sorry, this was plus 1, not minus 4. I don't know where that came from. 1x plus 1. Okay, so now if I take out a minus 1, that makes a lot more sense because then I'm left with x minus 1 inside. So I have 3x minus 1 and then x minus 1. Okay, I'm going to see what I can cancel out of here, but I know that I'm not done simplifying yet. So I can cancel out these 3x. Because top and bottom, it doesn't matter which part they're on. And then I can cancel out these x minus 1s. All right. I see this 1 minus 9x squared. It looks like a difference of 2 squares. So I have 1 minus 3x and 1 plus 3x from this numerator, 1 minus 9x squared. Then I have 3x plus 1 in the denominator here. And then I have times 3x minus 1 over here. Nothing on the bottom, so it's a 1 on the bottom. I can put these in parentheses if I want. Okay, so then I notice 1 plus 3x and 3x plus 1 are the same thing, just written backwards. So then I have nothing left on the bottom. I have a denominator of 1. On the top, I have 1 minus 3x and 3x minus 1. One thing I can do if I really want to is I can factor a negative 1 out of this first one. So if I take a negative 1 out, I end up with negative 1 plus 3x or 3x minus 1. So I have 3x minus 1 times 3x minus 1, 3x minus 1 quantity squared. So all of this original problem simplified down to just that. Let's try one more of these. So on this one, what I see is this is really 9x squared minus 6x plus 4 over 1. if you want to keep track of what's in the numerator, what's in the denominator. I want to see what I can take out of all of these things, what I can simplify out before I try to combine anything. So I have x plus 2, there's not a whole lot I can do there. What I see is the sum of cubes here. So remember, we take the cube root. So the cube root of 27x cubed would be 3x. Cube root of 8 would be 2. And then we square it, so 9x squared. We multiply it, so 6x. And then we square it, so 4. And then SOAP, same sign, opposite sign, always positive. So by taking the time to do that first, what I notice is I could have factored, or could have tried to factor this numerator, but I see that these are exactly the same. So that cancels. So then I'm left with x plus 2 over 3x plus 2. Really tempting to try to cancel out that x plus 2 since it's on the top and the bottom and just say your answer is 1 over 3, but we can't break it apart. If it looked like, I'm going to write this in a different color and I'm going to cross it out when I'm done. If it looked like x plus 2 over 3 and then x plus 2, then it could be canceled because the 3 and the x plus 2 are being multiplied. But that's not the case in your answer. This is not what we have. So we cannot cancel out those x plus 2's. So that's your final answer on that one. Okay, the last piece we're looking at is dividing. And so when we divide, the only difference is that we flip over the second fraction when we divide. So we're still looking for things that we can cancel out. So I'm going to go ahead and as I look for those things to simplify, to factor, I'm going to go ahead and flip that fraction over when I do that. So the 3 on top, there's nothing I can do with. 4x minus 8, I can take a 4 out of there. I'm left with x minus 2. Now, multiplying, so I'm flipping it over. So what I'm looking at right now is this x squared plus x minus 6, because that's going to be my new numerator when I multiply. So I need two things that multiply to negative 6 and add to positive 1. So that should be plus 3 and minus 2. So x plus 3 and x minus 2. Now my denominator, I have x squared plus 3x. I can take an x out of there, and then I have x plus 3. So then you should see a few things matching, and it looks like I'm just left with 3 over 4x. Guys, at any time if you are feeling comfortable with these and you want to try them on your own, go ahead and pause the video to do that. Okay, so this next one, this 4x squared minus x is in the numerator, so there's a denominator of 1, but remember we're going to flip that over in just a second. So I'm going to look for what I can take out of 8x squared plus 10x minus 3. So I need something that multiplies to negative 24 and adds to positive 10. So I need negative 24 so that would be a positive 12. Oops. And a negative 2. So then I have 8x squared plus 12x minus 2x minus 3. So then I can take a 4x out of there. I have 2x plus 3. and I can take a negative 1, so I have 2x plus 3. So this numerator would be 4x minus 1 and 2x plus 3 over 4x squared. Now remember, I'm flipping over the fraction, so I have 1 over. I can take an x out of this, and I have 4x minus 1 in the denominator. So my 4x minus 1s will cancel, and that looks like that's it for what I can take out. So let's see. Back to green. 2x plus 3 times 1 over 4x squared times x, so 4x to the third. And that's our final simplified answer. Okay, for this last one, we have to we have 3 pieces here. So I'm going to put this over 1. Notice we have to flip that last one over. So I have x over x minus 2. And then I'm going to keep 2x plus 3 over 1. Nothing I can simplify on these, so I'm just leaving them as they are. But then I'm going to flip this over. So I have x minus 2 over, and then I have 4x squared minus 9. That's a difference of 2 squares. So I have 2x plus 3 and 2x minus 3, and that's all I can simplify in there. So I'm going to cancel out these x minus 2's. I'm going to cancel out this 2x plus 3, and then that looks like everything I'm able to do. So the only thing I have left on top is x. The only thing I have left on the bottom is 2x minus 3. That's my final answer. So that's all I have for this set of notes. If you have any questions, feel free to come in and see me. Otherwise, I'll see you in class.